Have you ever wondered about why space suits are actually in the vacuum of space, your blood would literally boil. Keeping you alive means inflating the suit like a tire. Inflate a glove and watch it turn stiff and rigid. Engineers use complex joints to allow movement under high pressure. The suit acts as a tiny, pressurized, mobile life support bubble. Every single movement requires fighting the suit's internal gas pressure. Multiple layers keep the balloon shape while blocking deadly radiation. New designs use tight fabric instead of air for pressure. That detail becomes important later. Inside, the suit is filled with high pressure, ballooning outward. Moving your arm is like bending a fully inflated tire. Without this pressure, your blood would boil in seconds flat. Engineers use complex bellows to keep the joints from locking. It is a battle between human mobility and lethal pressure. The inner bladder holds the air, the outer shell protects. Simply keeping your hands closed tires out your forearm muscles. Specialized fibers prevent the suit from popping like a balloon. You are basically trapped inside a pressurized, human-shaped air tank. Wait until you see how we solve the glove problem. Inside that suit, you are trapped in a giant balloon. Space has no pressure, so the suit pushes back hard. Without layers, the suit would expand into a rigid sphere. A strong restraint layer keeps your limbs from ballooning out. Bending an elbow is like trying to fold a tire. Engineers build joints that keep the internal volume perfectly constant. This trick stops the suit from wanting to straighten itself. It is essentially a complex dance of fabric and air. You are basically a human inside a very expensive balloon. But what happens when that balloon starts getting too hot? Internal pressure makes every limb act like a stiff balloon. Bending your arm requires fighting against the suit's rigid shape. Engineers must balance human movement with extreme internal gas force. Constant volume joints help prevent the suit from fighting back. Multiple fabric layers hold the pressure while maintaining suit shape. Outside, the vacuum of space wants to expand the suit. Without this structure, the suit would balloon into a sphere. Advanced polymers ensure the suit remains flexible, yet incredibly strong. Wait until you see how next-gen suits change the game. Inside that suit, air pressure makes it a stiff balloon. Bending your arm is like crushing a fully inflated tire. The vacuum outside pulls, while internal pressure pushes back hard. Engineers use constant volume joints to keep the shape stable. Tiny internal cables prevent the suit from bulging like balloons. Astronauts burn massive calories just to open their own hands. Mobility is limited because the suit wants to stay straight. Multiple layers of fabric balance pressure against total human safety. New designs aim to make these balloons feel like skin. Inside the suit, air pressure forces the fabric outward constantly. It acts like a balloon, resisting any attempt to bend. Bending your arm requires fighting the suit's own internal volume. Engineers add metal bearings to allow joints to rotate smoothly. The suit is a pressurized balloon shaped like a human. Hit the subscribe button and press the bell icon to get updates. Without this pressure, your blood would literally boil in space. Multiple layers protect you while keeping the air inside trapped. It is a balloon that keeps you alive against space. Without internal pressure, your bodily fluids would literally boil away. Your suit is a balloon holding a human-shaped atmosphere. Inflate a glove and try to close your fist today. Engineers use complex joints so the suit volume stays constant. If volume doesn't change, the suit won't fight your movement. It is like a bellows accordion keeping space inside constant. This clever design allows astronauts to perform delicate repair tasks. Beyond the pressure bladder, layers protect against extreme solar radiation. Stay tuned to see what happens when the suit fails. In space, there is zero pressure to hold you together. Your suit is essentially a balloon filled with breathable air. Without this internal pressure, your body would swell quite uncomfortably. Try bending a garden hose while it is under high pressure. Engineers use clever constant volume joints to keep you moving. The suit also acts as a thermos for your body. Outer layers protect you from tiny, high-speed space rocks. It is a complex dance between physics and human biology. The evidence points to a much deeper story.